Hello, statisticians, and welcome to Section 7.4 Excel tips on the central limit theorem for proportions. This is going to be a similar in idea to what we saw with the central limit theorem for means, where we had a sample and we were looking at the average and adjusting the standard deviation for that sample. We're going to also adjust our standard deviation here for proportions with a slightly different formula because we're in the context of proportions, which means it's important we're able to identify when we're talking about a proportion as opposed to a mean. A proportion is talking about a percent out of a whole. It's going to be a decimal less than 1. It might be the number of rainy days out of the week divided to give you a decimal. We might take the number of widgets that were successfully made out of the total widgets that were made. Or in this case, the example we're going to do here is the percent of voters that support a levy. It's a part out of a whole, not an average, it's a proportion. The Excel command for this is very similar. It's going to be equals norm.dist. Instead of x bar or the x, our interesting value is going to be p hat. P hat is the proportion from the sample. Be very careful not to confuse it with p, our next argument. P is the proportion from the population. So first is your sample, comma, then the population proportion, which acts like the mean in the command, comma. For our standard error, it's a big square root. So we'll do a square root, open parentheses, p times, open a parentheses, 1 minus p, close the parentheses, divided by the sample size and close the parentheses. That's our standard error formula for proportions from the central limit theorem. And then we'll finish with comma true, just like always. So for this case, it's estimated that 68% of voters voted in a recent election. That is of all voters, so that is our P. We want to know that the probability of a group of 45 people, that's our sample size N, less than 30 voted. So we don't actually have our P hat here. To get our P hat, we can have Excel calculate it for us. P hat is equal to, we'll use our equals, the 30 people who voted out of 45. P hat is 0.66667. Now we're ready to draw our picture. We've got a normal distribution with a mean in the middle that's equal to the proportion of the entire population at 0.68. Our value is 0.66667, which is less. And we want to know if there is less than that voting, so that's going to give us the left tail, which is excellent because we know that the Excel command for the normal distribution always gives us the left tail. So I can say equals norm.dist, open a parentheses. Our x value is going to be the p hat from our sample. To make sure it's exact, I'm just going to click the value so that it gets stuck in my formula. Comma. In place of the mean, we're going to use the proportion of the population, p, which is 0.68, comma. The standard deviation is going to be that big square root formula to calculate the standard error used for proportions. SQRT for square root. Then we'll use our proportion from the population, 0.68, times, open a parentheses, 1 minus the proportion, 0.68, close the parentheses on the 1 minus, divided by the sample size. We said there were 45 people. Close the parentheses then on the square root and hit comma. And we always end with true. Close the parentheses on the whole normal distribution, and when we hit enter, we find out the probability a group of 45 people less than 30 people voted is 0.4239, or about 42%. Let's do one more example. We draw our distribution here, and in the middle is the 0.68. And again, we have to calculate the p hat, or the proportion from our sample. Of 75 people, we want more than 49 to vote. We'll say equals 49 divided by 75 to get our proportion of 0.6533. That's also to the left. And we want the area to right because we want more than that to vote. Because we want the right tail, we're going to use the complement, starting with equals 1 minus. Then we'll type in our normal distribution function, norm.dist, open a parentheses. X, the value we're interested in, is our p hat, which I'll go ahead and select to make it accurate, comma, the mean in the center of my distribution is 0.68, the proportion of the population, comma, for the standard deviation, it's the big square root from the central limit theorem, SQRT, open a parentheses, the population proportion of 0.68 times 1 minus the population proportion of 0.68 divided by the sample size, in this case is 75. I'll close the parentheses on the square root and finish with comma true. Close the parentheses and I find out that the area to the right, having more than 49 people voting, has a probability of 0.6897. Now some students prefer to calculate the standard error separately and then use the standard error in the formula, and that works just as well. Let's calculate the standard error and try that. For the standard error formula with proportions, we can say equals SQRT, open a parentheses, 68% is the population proportion, so 0.68, times 1 minus 0.68 in parentheses, divided by the sample size of 75. Close the parentheses on the square root and we find out the standard error is 0.053864. Now I can answer the same question by hitting equals 1 minus, because we're doing a complement, norm.dist, open a parentheses. The p hat value I'm interested in is the 65. I'll select it, comma. The mean, the center of my distribution, is 0.68, comma. We're going to use the standard error that I just calculated by clicking it, comma, true. And that might clean up the command a little bit. When we hit enter, we get the exact same area or probability of 0.6897 that more than 49 out of 75 people voted.